We will now understand about the working of the rapid gravity filters. The rate of filtration in case of rapid gravity filter is very high, generally at the rate of 4000 to 6000 liter per hour per square meter of surface area of the filter. Moving about the efficiency of rapid gravity filters, it is highly efficient in removal of color. It is less efficient in removal of bacteria. It can remove turbidity of up to 30 to 45 NTU. We shall now understand about the troubles encountered during the operation of rapid sand filter. The first one is the loss of head. The water has to face a frictional resistance when it passes through the filtering media, that is, when it passes through the sand and the gravel. That is, when the water percolating to the filter moves in the downward direction under the force of gravity. This motion will be opposed by the resistance that will be offered by the sand grains and the impurities that are arrested amongst them. The percolated water therefore loses some of its head, and the loss of head can be computed by knowing the water level in the filter and the pressure of water in the outlet pipe. The difference between the two heads will give the loss of head, what we call as filter head or filtration head. This loss of head is measured by inserting two piezometers, one in the water standing over the filter and other in the outlet pipe as shown in the figure here. The difference in the readings of these two piezometers will give the loss of head. While when the filter is newly commissioned, then the loss of head is generally very small and will be of order of 15 to 30 centimeter. However, the loss of head goes on increasing eventually, and as more and more impurities get trapped into it, the loss of head increases. A stage is finally reached when the frictional resistance offered by the filtering media exceeds the static head of water above the sand bed. Most of this resistance is caused by top 10 to 15 centimeter sand layer. The bottom sand then acts like more or less a vacuum, and the water is sucked through the filter media rather than getting filtered through it. The fall of mercury level in the piezometer inserted in the outlet pipe below the center line of the pipe will indicate the presence and extent of negative pressure created. The negative pressure so developed tends to release the dissolved air and gases present in the water. The formation of bubbles takes place upon the release of the gases, which will stick to the sand grains and thereby affect the working of the filter. The phenomenon is known as air binding, as the air binds the filter and stops its functioning, thereby reducing the rate of filtration significantly. In order to avoid such troubles, the filters are cleaned as soon as the loss of it will exceed the optimum allowable value. On an average, the loss of head is generally limited to around 2.5 to 3.5 meter and the negative head to about 1.2 meter. In addition to air binding and formation of the negative head, the two other common troubles which are generally encountered during the operation of rapid gravity filters are formation of the mud balls and cracking of the filters. The mud from the atmosphere usually accumulates on the sand surface so as to form a dense mat. In fact, this will be like an additive which starts becoming a clogging particle. During inadequate washing of the filter, this mud may sink down into the sand bed, and this mud then sticks to the sand grains and other arrested impurities on the grains, which forms the conglomerations of mud balls, that is from the turbidity and the flocks. These mud balls slowly goes on increasing in size and weight, and they start sinking down into the gravel, which will in turn interfere with the upward movement of the wash water, that is during the backwashing, and they even cause turbulence around them and hinder the uniform application of the wash water. Because we know that the uniform distribution matters much during the backwashing process. The high velocities created around the edge of these balls will displace the gravel and thereby forming the mounds, while above the balls the sand is improperly washed and mud accumulates. Means to tell that when once the mud ball formation starts, they go on increasing in number and density until the entire space in the filter box get filled up with them. The use of surface wash technique instead of old conventional backwashing technique is proved to be very successful in eliminating the formation of mud balls. These mud balls may be even removed by breaking them up with some rakes or some other equipment and then washing off the particles. And even it could be washed done by washing the filter with some solution of caustic soda or some other such chemicals. So now about the cracking of filters. The finer sand that are in the top layers of the filter bed start shrinking, and this causes the development of shrinkage cracks in the sand bed. These cracks are more prominent near the junctions, that is on the walls. With the use of filter, the loss of head and therefore the pressure on the sand bed goes on increasing, which will further start becoming widened. The flock mud and other impurities arrested in the filter penetrate deep into the filter through these cracks and thus impairing both the washing of the filter and the efficiency of the filter. The rate of filtration that can be obtained from rapid gravity filters is very high and is generally of the order of 3000 to 6000 liters per hour per meter square of the surface area. This high rate of filtration leads to considerable saving of the space and even the filter materials. Coming about the efficiency and performance, rapid gravity filters in comparison to the slow sand filters are less efficient in removing bacteria and turbidity. They can remove only up to 80 to 90% of the bacterial load that is present in the water. The remaining bacteria are to be removed in the further process, that is during the disinfection. They can remove turbidity only up to 35 to 40 NTU, but since the water entering these filters are given pre-treatments in coagulation sedimentation tank, they are comparatively less turbid. Such turbidity can be easily removed by these filters and brought to the permissible limits. And as far as the color removal is concerned, they are highly efficient and can bring down the color to as low as 10 on the cobalt scale. So, what are the uses of the rapid gravity filters? They are best used in case of public supplies and most economical one in comparison to the slow sand filters. They are especially used for the municipal supplies of large towns and cities. The treated waters are, however, not so much safe and it needs some disinfection. That means they need further treatment before they can be supplied to the general public. Next is about the pressure filters. They are just like small rapid gravity filters which are placed in closed vessels and through which water will be treated passing under high pressure. Since water is forced to such filters at a pressure greater than the atmospheric pressure, it is necessary that these filters are located in airtight vessels. The raw water is pumped into the vessels by means of pumps and the pressure developed may normally vary from 30 to 70 meter head of water, that is 300 to 700 kilonewton per meter square. The theory is based on the fact that if water is sent under pressure to the filter media, then the rate of filtration will be high. The quality of sand and gravel are kept similar to that of rapid gravity filter, and the base material and the filter media are enclosed in a cylinder through which water is sent under pressure. Moving on to the construction, it is a closed cylinder made of steel sheets by riveting. The diameter of the cylinder varies from 2 to 4 meters and the length varies from 4 to 8 meters. Two manholes are provided on the top for inspection purpose, and it consists of inlet pipe from the coagulation tank and an inlet for wash water. Compressed air and a wash water drain are also provided. The gravels and the coarser sands are placed over the under drainage system, which consists of a central drain and the lateral drains. So these are the laterals. So how about the working? In normal working condition, the walls V1 and V2 are kept open and all of the walls are kept closed. The water enters the chamber through the inlet pipe, and on the top it passes through the filter media under pressure. The filter water is then discharged to the outlet pipe and stored in a storage tank. So how about the cleaning process? When the rate of filtration starts decreasing, that is due to the deposition of impurities on the top surface of the filter media, it is a clear indication that the filter requires cleaning. So during cleaning, the valves 1 and 2 are closed and valves 3 and 4 are open. The wash water and compressed air are sent through the base materials in an upward direction. The compressed air agitates the sand grains and the wash water will wash the impurities adhered to the sand grains. The dirty water is exhausted through the wash water drain. The rate of filtration is very high, that is about 6,000 to 15,000 liters per hour per square meter of the surface area of the filter. And moving on to the efficiency, the pressure filter is less efficient in comparison to the rapid sand filter in removal of turbidity, color, and bacterial load. It is not suitable for public water supplies and it is suitable only for the industrial plants, private estates, small colonies, etc.